Hello. In this video, we are going to learn how to graph quadratic functions in Vertex form, which means we're using our translations. Quadratic functions, the parent function is y equals x squared. If we were to create a table of values, we can plug in -2, -2 squared is 4, -1 is 1, 0 is 0, 1 squared is 1, and 2 squared is 4. So that translates directly to ordered pairs, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now let's graph all four of these points. There we have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Connecting them with a nice smooth curve, we see our parabola. We see that our vertex is 0, 0, and that it's a minimum. So let's review our translations that we learned in Unit 1. Anytime that we add something to the outside of the function, that means we're going to move up. Anytime we subtract something from the outside of the function, we're going to move down. If we subtract on the inside, remember on the inside it's opposite, which means we're going to move to the right. Add on the inside, we're going to move to the left. A negative out front means we're going to reflect across the x-axis. A negative on the inside means we're going to reflect over the y-axis. Whenever we multiply by a number that's bigger than 1, so maybe like 3, that's going to be a vertical stretch, meaning that the function is going to get skinnier. And anytime that we multiply by a fraction that's in between 0 and 1, so maybe 1/2 or 3/4, it's going to be a horizontal stretch, meaning the function gets wider. Vertex form of a quadratic function is f of x equals a times x minus h squared plus k. Let's break down what all this means. So here we have a function x minus 2 squared plus 1. What we notice is that our a is positive because our a is 1, and so it's going to open up. We see that there's a -2 on the inside, which means we're going to move to the right 2, and a +1 on the outside, which means we're going to move up 1. Since we move to the right 2 and up 1, our vertex is 2, 1. And because our x value of our vertex is 2, our axis of symmetry is x equals 2. So the graph of this function can be seen here. You can see that the minimum of our vertex is indeed at 2, 1. And you can see that the axis of symmetry is 2. So let's do a complete example. We're going to determine the vertex, the axis of symmetry, and the direction of the opening. Our function is -4 times x plus 1 squared minus 7. Now, the +1 on the inside means that we move left 1. The -7 on the outside means we move down 7. So our vertex going left 1, down 7 means we're at a -1, -7. Our axis of symmetry is the x portion of our vertex, so that's -1. Then we need to look at this -4. It's negative, so that means that we're going to open down. On this example, we're actually going to graph the quadratic function, but we still have to include those steps that we just looked at. So +2 on the inside means we're moving left 2. -4 on the outside means we're moving down 4. So we know our vertex is -2, -4. Therefore, our axis of symmetry is -2 because that's the x part of our vertex. Now we understand that there is a 1 in the front, which means that we're going to open up. And let's go ahead and put our vertex on the graph. So we start at the origin. We're going to shift it left 2, down 4, just like that. And our axis of symmetry is -2. Now, we know that we need additional points to be able to finish out this parabola. So let's think about some things. If I square 1, that's going to be 1, right? If I square 2, it's going to be 4. And if I square 3, it's going to be 9. So maybe you're saying, but Ms. Jordan, why are you squaring these numbers? Because that's what a quadratic function is. Our parent function was x squared, right? Okay, that's a quadratic function. So we're squaring 1, we're squaring 2, we're squaring 3. These three numbers, 1, 4, 9, are the three numbers that you need to commit to your memory. Ingrain them in your brain. If you need help and you reach out to me for assistance on a problem, I'm going to tell you 1, 4, 9, 1, 4, 9, 1, 4, 9. This means that we're going to go out 1, up 1, out 2, up 4, out 3, up 9. Okay? Now, we know that a quadratic is a symmetric function to its axis of symmetry, meaning it mirrors across its axis of symmetry. So what we're going to do is we're going to take these 3 points and we're going to mirror them across the axis of symmetry. And then we're going to connect them with a nice smooth curve. So there's our graph. We can see that our vertex is the minimum and that our zeros are -4 and 0. Let's graph another quadratic function. This time we have -2 times x minus 3 squared plus 4. The -3 on the outside tells us, on the inside tells us we're going to move to the right 3. Plus 4 on the outside means we're going to move up 4. So our vertex is 3, 4. Our axis of symmetry is our x of our vertex, which is 3. And then we have to look at this -2. Because it's negative, we know that our parabola is going to open down. Therefore, our vertex should be a maximum whenever we finish graphing. Now this time, let's go ahead and graph our vertex. Forgot about that. Sorry. So we're going to go right 3, up 4. And then we see our axis of symmetry. But this time, instead of using 1, 4, 9, we have to account for the fact that we have this -2 out front. So we're going to multiply 1, 4, and 9 all by -2. 1 times -2 is -2. 4 times -2 is -8. 9 times -2 is -18. What this means now is that we're going to go out 1, down 2. We're going to use these values right here, -2, -8, -18. So we're going to go out 2, out 1, down 2. Then we're going to go out 2, down 8. And then we would try to go out 3, down 18, but we know that we can't fit 18 on this graph. So once again, because a quadratic function is symmetric, we are going to reflect these points across the axis of symmetry, so we're going to drag them over, and then we're going to connect it with a nice smooth curve. And so that is how we graph this function using translations, and then compared to how we graphed functions in standard form yesterday. So that concludes this video.